Hello, everybody. My name is Nick Barcet, and I'm going to be presenting with Mark Schmitt about edge computing with Red Hat OpenShift. I am the Senior Director of Technology Strategy at Red Hat. I've been working on the edge topic for the past 2 years. And Mark, why don't you introduce yourself?
Yep. Hello, Mark Schmitt, Technical Marketing Manager in the Cloud Platforms Business Unit at Red Hat. Also focused on edge computing for probably the last year and a half.
So, very quick disclaimer, we are showing some dates that are in the future. So I have to say that anything may change because nobody knows the future. The overall vision, I think, was presented quite clearly by Troy earlier today. But in a very big summarizing statement, OpenShift Everywhere, so that you can deploy the same application at whichever place, on whichever footprint you like, without having to recode anything. That's the big proposal that we have. And this proposal was there and has now been extended all the way to the edge. So I'm going to go directly into a little bit of explanation on the architecture that we are seeing to solve for the edge. So first of all, the edge is many different things to many different people. Depending on your use case, depending on your number of sites, you're going to have multiple layers of the edge. Some part of the edge can be happening on some provider edge. They would be the one hosting the edge, or they would be the one providing services on the edge. And some part of it can happen on the customer sites. And there can be 2, 3, 4 layers, depending on the number of sites you have to deal with, depending on the geography you're going to deal with. So this slide is just to say that there is not a one-size-fits-all in terms of edge. Everybody is going to have their own set of requirements that will lead to different topologies. Consistency is really our key point with OpenShift. They provide the same experience wherever we are deploying. But in order for this to happen, we need for the infrastructure to be deployable in all of these scenarios. So what are the scenarios that we envision and that we are delivering? It's quite simple. Starting from the bottom, we can have a small site that needs to have full resiliency on site, that needs to deploy an application that needs to be completely HA, but we don't have the room to fit a whole data center there. So for this, a 3-node cluster, or more nodes, but 3 is the minimum we know how to do HA properly using Kubernetes, is the right answer. And what we've done here is, compared to a standard OpenShift deployment where you have your control plane that is separated from your workers, we've combined the workers and the control plane on the same physical server. And you can additionally, using our storage technology, deploy the storage on the same 3 nodes. So you have something really compact that is ready to host application, highly available. A second topology that we've recently announced less than a month ago is the notion of remote worker node. In that case, we have a control plane that is centralized somewhere, and you have remote workers that are quite far away from it, that are controlled by it, meaning that you can deploy 1, 2, 3 nodes on thousands of sites controlled by a single control plane, maximizing your resource usage and enabling deployment on a variety of sites. So where would we see that? We would see that in a typical case where we want to deploy workloads on site that have good network connectivity. And when I say good, I only mean good in the sense of reliable. The connection is there to stay. It's not a site that is typically disconnected unless there is some major catastrophe happening. In terms of requirements, for example, the remote worker node can be up to 200 milliseconds away from the control plane. The bandwidth, we have no minimal requirement other than what is acceptable by the user using the application and deploying the application. However, if you're on a site where you know you're going to be disconnected at some stages, that's where you would need the third topology, this notion of single node edge server, which allows for the control plane and the worker node to be deployed all by itself. And in this case, you have an extremely resilient connection, well, up to the time where that server fails, but it's resilient to connection failure, and you have the ability to run workloads on it. So with these three topology, we obviously need a tool to offer management of one or all of them being deployed on multiple sites. And that's where Red Hat Advanced Management for Kubernetes comes into play, as it allows us to manage thousands of clusters as if there were one, with the ability to not only manage the infrastructure, but also the workloads, and all this using GitOps methodology, meaning that it's a code repository that is at the center of it all, and each one of our cluster pulling information from it whenever the connectivity is available, and reporting about what's happening on the various sites on a regular basis.
How, I guess my question is around flexibility in terms of the control plane and the worker nodes. Does it have to be a single node at that edge site? Or if you could squeeze in two nodes, could you do that?
Yes.
Or is it, you could, okay. So there's some flexibility there.
The smallest you can do is one node using remote worker node, but you can grow to 2, 3 or more.
Okay. And that separation of the control plane from the worker nodes, like how many worker nodes could you realistically manage with one of those control planes in the regional data center?
I believe we have tested up to 2,000 nodes per control plane.
Okay. So that's pretty sizable.
Yeah. And of course, we have, I'll show you a few use cases in a moment, but we have customers that have more than 2,000 something to manage where they need one node there. And in this case, what we do is we have an intermediary level of aggregation where we have a control plane for the 2,000 first one, a second control plane for, and actually it's seen as an addition of cluster that are managed through ACM.
Okay, and all of these are running Kubernetes?
All of these are running Kubernetes. Actually, the control plane is the one running really Kubernetes. The other one are running pods.
Okay, and they just have like the kubelet running to talk back. Okay. Last question. Are you, as Red Hat, providing the physical hardware for this, or are you partnering with other OEMs for the hardware?
I don't believe that Red Hat has ever sold any type of hardware, but we are partnering with the usual suspects in delivering this architecture. I don't think there is a single hardware vendor nowadays that doesn't offer their hardware with OpenShift.
Okay, great. Thank you.
Is that driven by you guys? So do you say we need at least this in amount of hardware? So is there an HCL that you provide to the partners, or is it the other way around?
So it really depends on the engagement. If the architecture is built by our professional services, we will be the one telling what is needed. If it's a third-party SI, one of our partners doing that, they will be the one. If the customer has the internal knowledge, they will be the one dictating that. Our role is to provide the tooling to have the largest amount of flexibility. Okay, so I'm not going to be spending a lot of time, but ACM is a really key component in our edge story. Without ACM, we could not pretend to build an edge if it was not managed. ACM is a tool that has a graphical UI as well as an API, uses a GitOps model, and knows how to apply policies to drive the governance, knows how to evaluate the compliance of a deployment, and it also knows how to do the application lifecycle management. So by tagging your various edges, it's really easy to determine where a given workload needs to be deployed. And once you've linked a location with a workload, the workload will get deployed automatically on all of these locations. Once you say update, it will be updated on all of these locations. And since it's a pull mechanism, there is no necessity for an agent to be connected at the time you send the order. The event will happen the next time the cluster checks in. Okay, so of course, Red Hat is not just delivering OpenShift. This presentation focuses on OpenShift, but as we go through use cases, we very often find that delivering the edge is a lot more than just delivering the infrastructure. You also need tooling to organize the flow of data. The edge in general is all about putting the compute resources as close as possible to where the data is being used or is being generated. So tooling to handle this data at large is super important. And in our middleware portfolio, we've got lots of tools that help for that. For example, we have an AMQP that allows to do MQTT transport. We've got Kafka. We've got Quarkus that enables building application that would go on very small devices, et cetera, et cetera. So we do look at problem a little bit larger than just the infrastructure problem. And I'm going to be talking in a moment about our use cases, because for us, use cases is what is driving the edge. It's not just an infrastructure problem, it's a business problem first. And for each business problem, you will need to provide an answer that is slightly different. So what are the type of use cases we are seeing? Well, the most common use case is about data management. And when we talk nowadays about data management, AI seems to be pervasive almost everywhere, in automotive, in manufacturing, in retail, in health, in energy, in the public sector. There is very often a motivation to go to the edge so that some form of AI or some form of data management is going to be able to react quicker to events detected locally. And what's interesting there is to understand the process that generally needs to happen. In general, what's happening when you're building an AI model, you're doing it based on data that you're bringing back from the edge site to the central site. You build a model, you test it locally, then you deploy it back on the edge site, maybe one or two to do a validation that you've not messed up, and then you want this new model to be redeployed on all of your edge sites. And that's a super common pattern in almost all use cases we've encountered, to have something like this, maybe not exactly about machine learning, or maybe not, but you always have this back and forth between where you do the development and where you execute what you've developed. There is one use case which is super important to Red Hat, because we've been working with telcos for a very long time. That is the less AI/ML infused, which is the how do telco deploy their 4G or 5G environment. And because of the growing number of bytes being exchanged on the wireless network, there is a need for the telco to completely decentralize the way they've been handling IP communication until now. And that's why you are seeing things that were not happening before, where compute power needs to be super close to the antenna in order for data to be exchanged with as low latency as possible. And this is why you now have a distinction between the central unit and the distributed unit. And by using OpenShift on all of these layers, you can have the same software executed on all of this. And using, again, our management tool, ACM, you are able to control all of your sites as if they are one. And typically, in a large telco environment, they will be combining 3-node topologies. They will be using remote worker nodes in highly dense area. They will be using single node OpenShift in more rural area where there are less antennas in order to meet the varying requirements. And we are currently working with multiple telcos on deploying this. Things are going really well. And this is a driving factor. But what is really interesting, it's the only use case where AI/ML has not yet entered. So as we are seeing this number of use cases growing, and these use cases implying the combination of multiple products, some of which are ours, some of which are partners, we realized that we needed a way to describe a deployment from A to Z. And previously people were doing that, building reference architecture. Then the reference architecture ended up being a big stack of paper with instruction on how to do a deployment. Well, nowadays, this doesn't make sense anymore. So we've decided to switch to this notion of blueprints, which really are GitOps repo containing the code to do the deployment. Make this in an open source way so that anybody can read, contribute, improve, and in a way that is highly reproducible so that we can use it in our CI to verify that when we release a new product, we are not breaking what was working before. We can use it at customer sites to do POCs or to do production. We can use it in various type of environment, including our internal Red Hat product demo system, so that our internal user can test it out and demonstrate it to our customer. And really, we've started this process about a year ago. We released the first blueprint just last month, and Mark is going to be talking about this in a second. But we think that this is a process that we are going to be using to illustrate more and more use cases as we go further into the edge.
Yeah, can you help give maybe some tangible examples of what the telcos are shifting out to the edge? I mean, I keep hearing that example and how 5G is really changing things and things moving out closer to the antennas and the towers. It's still not quite clicking with me, and I'm curious kind of what that looks like.
So let me give you a very simple example. With 5G, customers are expecting to be able to ping two components that are close to each other, connected to the same 5G antenna, in a matter of a few milliseconds, as few as possible. So really, they want the two phones or the two computers connected via 5G to be able to talk together as if they were on the same local network. If your packet has to do 4 hops to go back to the core of the data center of the telco before it goes back to this other equipment, you're going to lose so many milliseconds that you will feel like you're connected with maybe the other side of the city or maybe the other side of the country, depending on how big the network is. And that's how typical 4G deployments have been done so far. And what's happening right now is that we are moving the router, if you want, from being at the core of the telco data center to to be as close as to the antenna. I'm really oversimplifying here, but I hope that the people versed into telco won't kill me. But I think that's the best simple explanation I can give. Did this help?
Yeah, I think it helps. Connected devices, connected cars, connected city type examples. That's starting to make a little more sense when you describe it that way.
Yeah, and a big part of mobile networks is handing off from one base station to the next, right? And with 4G, you started to see more of that handoff taking place between base stations. 5G is going to accelerate that even more so.
Well, especially when you're talking about the high frequency, ultra wideband kind of implementations where you've got, multiple base stations per mile.
Exactly. So what we're talking about is really transforming industrial manufacturing to utilize a GetOps model. And that's going to allow industries to capitalize on the Industry 4.0 technologies to optimize, plan, and control, actual factory lines. It's a big transition from IT to OT from that business case perspective, especially when you throw in AI, ML, as well as the possibility of using hybrid cloud and software-defined technologies. But we're really talking and working with an actual customer in Europe to help them optimize production on the factory floor, using machine learning to actively predict when maintenance would be necessary on the floor itself. This also allows them to support future operating environments as well as scale, effectively. So, as I said, the use case, predictive maintenance of machinery, it's going to help the customer accelerate their software development. It's going to give them really a cloud-native application development environment. We also take advantage of automating configuration of actual data on production lines using declarative configuration management. And we actually use sensors that are simulated from the factory floor to actually feed a data stream so that the manufacturer can react proactively to that data. So the high-level overview of an actual customer shows that at the factory floor sites, the blueprints, simulated sensors, whether that's temperature, pressure, vibration, that provides a time series stream of data that's processed on the factory floor via Kafka. That is monitored on the factory site via a small web page and dashboard so that operators can see exactly what's going on with the production line. That data is then fed back to the core HQ data center as well, to the Open Data Hub environment, that can be utilized by data scientists to create machine learning anomaly inference models. So the Open Data Hub is really the foundation of an AI ML as a service platform. We're utilizing Ceph to provide scalable storage of those mirrored data streams, Apache Spark to analyze large data sets, and Jupyter Notebooks to create models. The core HQ data center also hosts the advanced cluster management. So if that particular client has multiple factories, you get a consistent approach to manage each of those across the hybrid cloud. Also at the site, or the core HQ data site, Tecton, Argo CD, Quarkus, Quay, and your developer's IDE of choice, whether that's Eclipse Che or VS Code, are used to run CI/CD pipelines, test images, and deploy applications and configuration changes to production. So the blueprint gives anyone the ability to demonstrate a modern cloud-native application development environment basic GitOps application deployment and configuration management, CI/CD pipelines, as well as multi-cluster management, and machine learning model training as well.
I have a question, and maybe it's more of a clarification of what you mean when you say a solution blueprint.
Mm-hmm.
Is that an actual infrastructure as code document that someone can deploy given they have the correct infrastructure, or is it more of a white paper idea?
Oh, no, it's actual GitHub code that you could fork and utilize to do yourself. So, yeah.
Okay. And is there a spec or standard that accompanies it? Or is it more of just an open?
We've reused the notion of blueprint that was developed inside of the Acrino project. And we've made it our own. But it's this idea of how to normalize a deployment.
Okay. Is the idea to make this an industry standard for edge deployments? So it'll just be another common format for people to use? Or is this specific to Red Hat and OpenShift?
There's nothing proprietary there. I'd be happy for it to become an industry standard, but I think the best standards are the ones that are not defined, but the ones that are being used. So if people feel like we've done it well, please copy.
Yeah, it is an opinionated Red Hat focused implementation, right? But again, as Nick stated, this is a fully tested solution, right? We have dedicated QE resources to go through and make sure that this is tested on a regular basis. Across BUs, I think too is the important thing there. Not just OpenShift, the cloud BU, but we also have a pretty extensive middleware as well as management feel in this blueprint as well. So cross BU testing is really key. Okay, any others? All right. So to dive down even deeper, this is kind of a much lower level view of everything that's involved in the solution. I won't spend too much time on this as you can get down in the weeds pretty quickly here. All right. So to finish up, this is a very edge-focused blueprint. As I showed previously, you can either utilize the remote worker node or the fully HA 3-node cluster at the edge sites. You can do coding, simulation, and deployment to production via CI/CD. There's automated configuration management that gives you consistent rollouts using end-to-end GitOps. And then the data processing from sensors to the analytics using open source middleware and AI/ML stacks. You can also do machine learning, model training, and deployment to production via Open Data Hub enabled CI/CD. Here is the GitHub repository for the blueprint, github.com, redhat-edge-computing. There is a full blueprint demo at the following YouTube link. It's about an hour. Or if you want to interact with us on a live demo here in about half an hour, you can go to the Twitch channel for Red Hat OpenShift TV.
One thing that we didn't talk about too much at the edge is really restricted functionality devices, something like a PCB or a Raspberry Pi is the common example. I've got one right here. One of those types of devices, is that eligible to be a worker node, or do you need something that's a little more robust?
We're going to need something a little bit more robust. The minimum requirement for a current worker node is, correct me if I'm wrong, Mark Schmitt, but I believe it's a minimum of 2 cores and something like 8 gigs of RAM.
It's six vCPUs, 24 gig RAM, and 200 gig storage. So right now, it's a pretty healthy machine that you're going to need to run Kubernetes on, right? And that's kind of a function of Kubernetes as well.
That's typically where our portfolio comes into play. We've got a new version of RHEL for Edge, that has been designed to run on these smaller devices. And that offers an equivalent of Docker called Podman that enables to launch container. Of course, it's not a dynamic system as is Kubernetes, but when you have such small device, generally the application that you're running there is fairly static. So you don't need a dynamic control plane.
Right. I guess that I was curious if there was something like the K3S project or there's some other, efforts to miniaturize Kubernetes or at least streamline it so it can run on these smaller form function devices. Is that basically what RHEL at the edge is intended to do?
Not at this point, but we are actively looking at these various solutions. There are multiple being in the research stage. I don't know of any that have reached now real production stage because it's early days on these modification. I think that if we were going to deliver something, it would need to be first upstream in a sizable community. I think if you make patches to Kubernetes, it should be delivered in the Kubernetes community, not a fork. And at that stage, when we have a stable platform, we'll certainly contribute and adopt it. But it's too early at the moment.
Okay.
Single node has been pretty much focused on telco initially, and those boxes will not be resource constrained. Right. So that's been the main focus, at least in the short term.